All right, what's up, everybody? Mr. Jones here. We're going to be going over Unit 3 in Algebra 2 here, and that is quadratic functions. Okay, quadratic functions are something we talked about in Unit 2, dealing with transformations, right? It was one of the 6 parent functions that we talked about. Okay, but now in Unit 3, we're taking a deep dive into the nitty-gritty of everything having to do with quadratics. Just some real basics before we get into it. Okay, quadratics are the key characteristic to those is that they all contain an x squared, okay? So all quadratics have an x squared or a 2 exponent in the equation, and that's the highest exponent that it has, okay? And then they also have this parabola shape when you graph them, okay? All graphs of quadratics are in that parabola curve shape, okay? So we're going to talk about all this stuff right now, just introducing you to it all, okay? And the first thing here is there's two different types of ways to write a quadratic equation, okay? Kind of two different forms of the equation, okay? So the first one is the standard form. So this is the standard form, y equals ax squared plus bx plus c, okay? You might have seen that before, and that is, again, the kind of the standard form, just listing all the terms, okay? Very basic, okay? And so we're going to learn more about how to graph these when you just look at the equation. Okay, it's a little bit more involved and it deals with a little bit more work, right? But that's one of the things we'll be learning here, okay? And then vertex form, you definitely have seen this before. All right, y equals a times x minus h squared plus k. All right, that is the vertex form. We saw vertex form with transformations, right? When we transformed and knew what all the shifts of our graphs were, right? This vertex form equation was what told us that, right? And we didn't call it vertex form, but that's what it was, all right? And again, this is a quadratic. It has that 2 exponent in it. It's just writing it in a different way. So we're going to look at equations that are in these two forms, all this unit, okay? But first, before we get into actual problems, let's get into these vocabulary terms, okay? You may or may not have seen these before, but again, we just have this example of this y equals x squared, right? That's our parent function of a quadratic, all right? So we're going to define these two words, these two terms, okay, as they relate to quadratics, okay? So a vertex, okay, you might have heard of vertex before, right? Dealing with angles. A vertex is the highest or lowest point on the parabola, okay? Or we could also call it a maximum or minimum point, okay? So when we look at this example graph, right, we're wondering, okay, what's the vertex? Again, that's kind of that lowest point, or that kind of, you wouldn't call it a corner because it's not right, it's not a corner, but there it is. Okay, that would be my vertex, okay, right there, that bottom point. So the coordinates of that, again, the coordinates right on the origin, right in the middle, 0, 0, okay? And yeah, that's my vertex, okay? That's kind of the middle point, or here it's the lowest point, okay? And so we would call that a minimum point here too, okay? We'd call that minimum, obviously, because that's the lowest point on the y-axis that it ever goes to, okay? If it opens up like a frowny face, like this, instead of a smiley face, we would call this the vertex, and it would be a maximum point then, okay? Now the axis of symmetry, the vertex and axis of symmetry have a relationship to them, okay? Now the axis of symmetry, I'll define it here. So the axis of symmetry is a vertical line that cuts the parabola right in half, right? And symmetry, again, symmetry is that word that kind of means the same on both sides, right? And so if we were to draw a vertical line, right, up and down, that would cut this in half, for this parabola right in the middle, it would be right here, right? That would be kind of that axis of symmetry, that line that cuts the parabola in perfect halves, okay? And so if I was to define that line, or write an equation that goes with this line, okay, you might remember from Algebra 1 that all vertical lines are equations that are just x equals, and then whatever number it crosses, or whatever spot on the x-axis that it cuts through, okay? Because again, all vertical lines do touch the x-axis at some point, okay? So we would say this is x equals 0, would be this axis of symmetry line, okay? And the relationship between the vertex and the axis of symmetry, right? That vertex point is always going to be in the middle, right? And so if the axis of symmetry cuts it in half, it's going to go through that vertex at some point, okay? And so it's that x-axis, or that's that x value in the vertex point that is always going to be the number of your axis of symmetry line. Okay, so that's the relationship there. So those are the key vocabulary and the new terms that we're going to see. Okay, now we're going to get into a little bit of the actual problems we're going to deal with, right? One of our big goals is graphing without using a calculator, graphing a standard form quadratic. So we're going to get into that and everything else here right now. So let me erase this and then we'll get into it. Okay, so let's get into it here. We got two quadratic equations, one in that vertex form, one in that standard form, and we are going to graph these puppies and answer this information about it. Okay, so again, we should be good with graphing these right now, right, already. So these vertex form equations, we should be pretty good at graphing those already, right? Because we compare that with the vertex form here, right? And we see our h and our k values here. And again, it's the same thing. It's telling us that horizontal and vertical shift, right? And so from the origin, right, it's going to move right 4 and up 3. Okay, so right 4 and up 3. What I didn't mention though is that again we didn't really talk about vertexes at all. I more called it like the origin point. Okay, because there's some of the like the square root graph and there's some of them that don't really have a vertex to them. But in terms of quadratics, yeah, we would call this the vertex. And so that h and k value are going to be the coordinates of the vertex, okay, which is cool. And so again, you have to keep the sign in mind, right? Because the standard is for it to be subtracting. So the vertex you see is at 4, 3, okay? And so that is the vertex of this, okay? And then again, it doesn't have an a value and it's not going to be flipped around, so we can just make that standard quadratic shape of up 1 over 1 to both sides, up 4 over 2 to both sides, and it'll look like this, okay? And so that's what this parabola looks like, okay? And then again, hey, there's this extra information here, okay? So again, remember the relationship between the vertex and the axis of symmetry. So the axis of symmetry, again, it's going to be that imaginary vertical line that cuts it right in half, going right through the vertex, okay? So where is that? What is that line? Well, it's always going to be x equals, and again, it has the relationship to the vertex because it's whatever the x value is on that vertex point. So it's going to be x equals 4, okay? So that's that axis of symmetry line. And again, it's also helpful to mention whether it's a max or a min. And again, it would be a minimum, okay, because this opens upwards and it has that lowest point there. So it would be a minimum, okay? And now talking domain and range, okay, domain for every single parabola, all quadratics will have a domain of all real numbers, okay, every single one, which is great. So that's one less thing to worry about. But the range isn't going to be the same thing every time, okay? This is, again, where we have to answer the question, is it going up and down forever? And no, it's not, right? So it only goes up to right here, right? That's the lowest it ever gets to, and then it goes to all numbers higher than that, okay? So we would say y is greater than or equal to 3, okay? That would be the range to this, all right? So again, pretty basic. We've done all that before other than the vertex and axis of symmetry, but that's pretty easy, right? Now that was so easy because we kind of knew what this was going to look like because we knew it right where the vertex was going to be without really having to do anything, okay? Okay, I changed up number 2 from where it was originally because I didn't like it before. I think this one will be a better intro, okay? So again, the difficulties we're going to have here are going to be that, like with this one, it was so easy to start graphing this because I knew, using my h and k values, I knew right where my vertex was going to be. And I don't have that here, right? I don't have this it written in this vertex form way. I don't have that written this way. So and no, it's not going to be at 6, 8. That's not where the vertex is here, okay? So, but there is one similarity, okay? You might remember the standard form of a quadratic. So the standard form of a quadratic is this, okay? The one similarity between this and vertex form is that a value, okay? That a value, and that represents the same thing here, okay? And so in vertex form, in my transformation form here, this represented, right, that number that told me if it was going to stretch or shrink and if it flipped upside down or not, okay? And so it's going to tell you the same thing here, right? So if there's a coefficient with the x squared, that's going to tell you if it's going to flip upside down or whatever, okay? The same thing. But again, I can't just jump right into graphing this because I don't know where my vertex is. I don't know where to start, okay? So for this, it requires a three-step process. And the first step is to find my axis of symmetry. Again, axis of symmetry. So that tells me right where the middle of it is, okay? Where the middle is. Basically, it gives me that x value of the middle of my parabola, okay? So for that, I use a very simple formula. So negative b over 2a tells me my axis of symmetry, and then so my a value, again, that just comes from the coefficients from my three numbers here. So a is 1, b is 6, c is 8. So I would do opposite of b, or negative b, so negative 6 over 2a, or 2 times 1. So negative 6 over 2 times 1, or 2, would just be negative 3. Okay, so that tells me, again, my axis of symmetry. So I know right now that my axis of symmetry is going to be at x equals negative 3. Okay, so I can write that down here too. So x equals negative 3 is going to be my axis of symmetry, and I can draw that. So that's all I know about my parabola right now. I know that is the axis of symmetry. That's kind of going to be where the middle is, and then it's going to be kind of going to either side of that. Okay, so that's the first one. That's number one. Okay, number two, the second step is going to be to use that to find my vertex, right? Because I know where the middle is on the x value, but I don't know what y value the vertex is at yet, okay? So here's what I'm going to do. I'm going to use that number that I found in step one, and I would substitute that in to my equation, okay? Because that's an x value, right? So I can substitute that in for x, okay? So I would do negative 3 squared plus 6 times negative 3 plus 8, right? The same equation, just with threes, negative 3's in for x's. So I would then solve that out, right? So negative 3 squared would be 9. 9 plus 6 times negative 3 would be negative 18. So 9 plus negative 18 is negative 9. Not negative 9 plus 8 is negative 1. So what did I just find? I found a y value, okay, of my vertex. Okay, so I found that y is going to be negative 1 when x is negative 3. Okay, so again, that's my vertex point. X is negative 3, y is negative 1. Okay, so I just found my vertex. So I know that point is going to be right here. Okay, that's where my vertex is going to be. From here, okay, normally I would have to then like find some more points. But again, using the principles that we learned in the transformations unit, okay, that a value, okay, we can kind of even save a step here. And no, right, normally we'd have to, plug in the values kind of surrounding negative 3, but if this a value is 1, which it is here, then I know that's going to have the standard quadratic parabola shape. So I can just go up 1 from that vertex, right? I can go up 1 and over 1 to both sides, and then up 4 over 2 to both sides. Okay, so we can use the same principles from the transformations unit, right, with my a value, okay, and I can use that to draw the rest of my parabola, okay? And so that's really helpful. Okay, so basically, it's a similar process, except it's way harder for me to find where my vertex is, right? The vertex in vertex form, that's why it's called vertex form, it tells you it's straight up, okay? But in standard form, I have to do this little bit of work to find where the vertex is, and then I can draw it. So then last step here, answering domain and range, okay? So the domain, again, as always, is all real numbers. And then the range, again, how high or low does it go on the y-axis? Well, it goes up forever, and it only goes down to y is negative 1. So it will be y is greater than or equal to negative 1 is my range. So that's it for this one. We're going to go over a couple more things related to standard form and vertex form, and then get into factoring. But that's all I wanted to show you right now, just graphing a couple of these guys. And then so we'll show one more video related to the equations here, and then we're done. So thanks for following. Good job.